hadn't seen you there. I was just fixing myself a beverage. A good year, that one. Oh, what's that? You're here to learn about the beautiful and awe-inspiring Base 12 system? Well, I will tell you that is a wonderful way to spend a Wednesday. Now, where to begin? Ah, I know. No, that's not it. Nope. No. Great book. Nope. I swear it was in here somewhere. Ah, yes, there it is.
Go.
Here's the book here. Many societies throughout history have used non-base 10 systems for measurement and mathematics. One of these systems was the base 12 system. The system was featured in several cultures, including inside the Nigerian belt, Nepal, and Maldives. In Proto-Germanic languages, such as English, it is worth noting that 11 and 12 have their own unique words. The reader should note that words such as 10-1, 10-2, 1-teen, and 2-teen are not used, but rather 11, 12 are unique words. In fact, in England for many years, currency and several measurements, including the number of inches in a foot, were based in base 12. It has also been common throughout history for time to be measured in increments of 12. Some suggest this is tied into the lunar cycles per year. One distinct advantage that early people found for the base 12 system was the ease of counting by using one's thumb as a pointer and the notches of the finger bones as counters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now look at that. For traders and merchants, base 12 was an ideal system for dividing goods, since it features factors of 2, 3, 4, and 6. I wonder what such a society might have looked like.
My oh my, what a marvelous day for sales. Things grouped by 12 for sale. Get your items that come standard as a dozen.
I would enjoy half a dozen items grouped by 12.
Ah, yes, of course. Well, 12 is easily divisible by 2, so such a task is very simple.
I haven't had the desire for that many, but perhaps 1/6 of a dozen items could set me straight.
A small quantity indeed, but a noble one, for 12 has a factor of 6.
Ah, 2 items. Perfect.
Ah, yes, another satisfied customer. All thanks to base 12.
My good sir, may I have 1/4 of a quantity of things grouped by 12, please?
Surely, because that's 3, another fine factor of 12.
Incredible! What a satisfied customer I am.
You there, customer 4. Perhaps I can interest you in a third of my items, grouped into 12s.
Well, that would actually be brilliant. I am customer 4 after all, and as anyone with good social logic knows, a third of a dozen is like me.
Oh, wonderful, wonderful. Another satisfied customer. All thanks to base 12.
My good sir, I would like to purchase 1/5 of a dozen items, please.
I'm afraid that we don't deal with decimals. I'm gonna have to ask you to leave, sir. A crab person? To think, I was nearly tricked by a dastardly crab person. Thank you, base 12, for saving me from the alien invasion.
Hi, my name's June,
Hi, my name's Barath.
and today we're going to be demonstrating how to clear our game Duodecimation. In our game, Duodecimation is sort of like Mancala with a slight twist. In our version, every player needs to move counterclockwise through the zones and drop the tokens into each place. But before you play the game, you must spin the zone spinner. This spinner determines which zones get multiplied by the amount of pieces you have. Let me demonstrate. Oh, we landed on 7. This means that since we got zone 7, that means both these zones get multiplied if you have your tokens in there.
My birthday is coming up sooner than June's birthday. I am player 1. So I'm going to be starting from zone 3, and I'm going to be moving counterclockwise.
And I'm going to be choosing zone 4. So 1, 2, 3, 4. After the 11th round of the game, you want to spin the factor spinner. This would determine how much your score gets multiplied in your specific zone. In our game, zone was a 7. So in the zones that are either 7 here, that means your score gets multiplied by the difference of black and white. So let's spin the spinner right now. That looks like a 3. So that means your score in the factor zones will be determined by the difference of blacks and whites, and then multiply that by 3. Yeah. During the 12th round of the game, you can choose to dump your tokens into a specific zone. However, you cannot pick up tokens in the design zone. So in our case, it was 7 and 7 here. So that means you cannot pick these up. However, any other tokens can be picked up and then dropped into the factor zones as long as it fits into the game rules.
So this is the process of calculating how many total points you have earned from the game. So in order to do that, you have to count up how many total tokens were on your side. In this case, I had 12 tokens that I received from the game. So using this knowledge, I just have to do 12 times 12 because each token is worth 12 points. So therefore, I got 144. And then from that, you just find the difference between my tokens and my opponent's tokens in the factor zone, which is 5 minus 3, or 2. Then you use this difference and multiply it by the spun factor value. So in this case, it would be 2 times 3, which is 6. Since this value is positive, I would just have to multiply 6 times 144, and that's how I get my final score of 864.
So we follow the same process for my score. So we do 8 plus 4, which means we have a total score of 12. Next, we multiply our total score by how many points each token is worth. So 12, so we get 144. However, in my case, if I take the difference in my factor zone, we get a negative number. That means we have to divide by that difference when you're calculating the final score. So this one will be 144 divided by 6, which is 24.